Hello everyone. So we are going to start the last part from the course dispersion, that is the part 13. So in this unit or in this part we are going to deal with the different types of equipments which are generally used in the pharmaceutical industry as well as in the laboratory scale for production of different type of emulsion. So without wasting any time, let's start the presentation. You see, so in this section we have two things. Number one, that is the extemporaneous method, and the next one, it is the large scale method for production of emulsion. The large scale method is also known as the scaling up of the techniques for production of the emulsion. So we know that basically the emulsion, they are prepared by either your dry gum method, wet gum method, or Forbes bottle method, and sometimes you can also use auxiliary method. So in the dry gum method, you see how we are going to add it: 4 parts of the oil, 2 parts of the water, and 1 part of gum. So this ratio, it is known as 4:2:1 method. Similarly, for wet gum method also we have the 4:2:1 ratio. In the Forbes bottle method, we have already discussed what is that. So we are here in the Forbes bottle, we are going to add them sequentially in the bottle, and afterwards we are going to shake it, right? And finally we have the auxiliary method. In the auxiliary method, we are going to use different types of equipment which includes hand homogenizer too, right? So the large scale method. The large scale method, you see, in the large scale method actually there are different physical parameters which affect the droplet size distribution of the emulsion in the large scale method. So what are the factors actually which affect the droplet size distribution of the dispersed phase, the viscosity of the dispersion medium, and as well as the stability of the emulsion? The factors which affect include: number one, it's the location of the emulsifier, where the emulsifier is located, at the surface of the droplet or the dispersed phase or in the dispersion medium. Number one, right? Number two, it is the method of incorporation of the phases. Which method we have adopted for incorporation of the phases? Either that is a wet gum method or a dry gum method or an auxiliary method, right? So it all depends upon the method, and this method, the way of this method, they will affect the physical parameter of the emulsion, right? Moreover, the rates of addition, how fast we are going to add this constituent to the emulsion, right? Then the temperature of each of the phase and the rate of cooling after the mixing of the two phases, right? It also affects the quantity or the nature or the quality of the emulsion. Now the energy may be supplied in the emulsion in the form of either your heat, or it can be supplied in the form of your homogenization or agitation. So let's discuss how the energy can be supplied. The first one, it is the heat. You see, the heat. Now you see, emulsification by evaporation, or you can say vaporization. We can use the heat energy to produce the emulsion. Here we are going to produce the emulsion, or you are going to emulsify the oil or the water phase by the principle of vaporization. Moreover, we can use the emulsification by phase inversion, right? And low energy emulsifier. So mechanical equipments for emulsification, that is by agitation. What are the different mechanical equipments you can use? Number one, the magnetics, or you can say the mechanical stirrers, which are available in our laboratory scale. Next one, it is the propeller mixture. Then we have the colloid mill and the ultrasonifiers. So how do they work? Let's discuss. Number one, mechanical stirrer. So you see, this emulsion can be stirred by means of various impellers mounted on the shaft, right? So this is the shaft and these are the impellers, right? So this is the motor. So by using this, we can produce different type of emulsification. So you see, this is used for actually this type of stirrers. They are used for mixing, suspending, sometimes milling, dispersing, disintegrating solid, etc. Right? Actually, what do this stirrer? They have simple. This stirrer, they have a rotor. They have a rotor, right? And one stator. The rotor actually, it remains inside the stator. The rotor, this is the rotor, you see, this is the rotor, it can move, and this is the stator. It will remain as it is. It will not change this position, but the rotor will change. So this is the general assembly of a mechanical stirrer. The next one, it is your propeller mixer. So it is a simple top entering from the top you can put the mixture, right? Top entering propeller mixture, right? It is educate for routine development work in the laboratory as well as in the production of the emulsion in the pharmaceutical industry. So the degree of agitation in the propeller mixture, it is controlled by the propeller rotation, how fast it is moving, either your clockwise, anti-clockwise, right? But the pattern of the liquid flow and the resultant efficiency of this mixing are controlled by the type of the impeller. There will be a impeller within this can, it will control, right? And the presence of baffles and the shape of the container. So these stirrers, they can be used, actually they cannot be used, this type of propeller mixture, they cannot be used when vigorous agitation is needed. If we need a vigorous agitation for production of emulsion, this cannot be used, right? Moreover, we cannot produce extremely small droplets. If we are going to use a propeller mixture, we cannot produce extremely small droplets of the dispersed phases. So foaming at a high shear rates must be avoided in using the propeller mixture. I repeat, foaming at a high shear rate must be avoided if we are going to use the propeller mixture. So this mixture, actually they may have the pedal blades, even they can also have the counter rotating blades or planetary blades, right? Regarding this type of instrument, I think we have already discussed in the pharmaceutical engineering chapter. If we just recapitulate what we have studied in the chapter mixing, the baffles, the mixture, the blades, the propellers, right? The next type, major type, it is the turbine type. Major type of propeller, turbine type. So this is the turbine, you see, this is a turbine, this is the rod, right? So if more vigorous agitation is required, you can use this turbine type. The next one, it is the homogenizer. This is the hand homogenizer, you can hold it in your hand. So nothing is there actually. Technically there is a motor. This motor can move at a very high RPM, and this motor, it is fitted with a shaft, right, where you have the rotor as well as the stator. So this type of homogenization, they raise the temperature of the emulsion, so hence the cooling may be required. Whenever we used to do emulsification, or sorry, we used to do homogenization by using this type of homogenizer, we always need to do cooling simultaneously, because this type of homogenizer, as they rotate at a very high speed, suppose 22,000 RPM, so you just imagine 22,000 revolution per minute. So when a homogenizer will move at such a high speed, definitely it will create some heat. So if we are going to prepare some emulsion, then we need to cool down the temperature during the use. So it can be generally used when a reasonably mono-dispersed emulsion of small droplet size around 1 nanometer is required. Means it is, this homogenizer are basically meant to be used for preparation of nanoparticles, nano emulsions, or different type of emulsification which actually deal with the smaller particle size. Clear? The next one, it is your colloid mill. So this is a colloid mill. It just operate on the principle of high shear, and which is normally actually generated between the rotor and the stator of the mill. Rotor, you know what is rotor? It is the moving part. So this is the rotor, right? And this is actually the rotor, and the bigger one, it is the stator, right? So the colloid mill, it consists of a fixed stator. This is the stator, it will be within this, and this is the rotor, it will move, right? So the material, it is drawn or pumped, it will come in between this, and when this rotor will move within the stator, they will get the agitation, they will get the mechanical shearing, which led to the destruction of the size, or which led to the breaking of the size, right? So the material, it is pumped through the adjustable gap between the rotor and the stator. It will just be put within this, right? And finally it will get what? It will get broken into smaller sizes, right? So by rotation of the rotor, which operates within, you see, 0.005 to 0.01 inch of the stator. You just see the gap, how when it will be placed here, the gap will be less, and within this gap the emulsion will be kept, just to reduce the size of the droplet. So this is a colloid mill. Clear? The next one, it is your ultrasonifiers, and it is also known as the ultrasonification method. So ultrasonic energy it is used to produce the pharmaceutical emulsion. But basically this type of instrument it is used in the laboratory scale actually, right? So they generally use the transduce, they use the piezoelectric device, and they have limited output and they are very expensive, thus they are used mostly in the laboratory scale. So they are useful for laboratory preparation, and for commercial preparation they are used, but the design is different. And for commercial preparation we follow the principle of form liquid whistle. This is the form liquid whistle for commercial one. So they are what actually happen here, the dispersion here at this thing, this is the inlet, this is the outlet, these are the vibration blade, these are the vibration blades, this is the inlet, it will be forced, and this is the vibration blade, they are going to do the vibration, right? So the dispersion it is forced through the orifice at a modest pressure, and it is allowed to impinge the blade, right? The pressure range is from generally the pressure is from 150 to 350 psi. The pressure actually it causes the blade to vibrate. This blade will vibrate, right, to produce a ultrasonic note. And when the system reaches a steady state, the gravitational field is generated, and around you see 60 tones psi can be achieved in commercial equipment. So this is a very general type of instrument that is used in the industry. So this actually works in the form whistle principle. Clear? Same only. Next, uses of the emulsion, where it is used. We have come through the whole chapter of emulsion, right? In the chemical industry, right? Cationic emulsion you can use for antimicrobial properties. Non-ionic emulsion you can use for, as they have low toxicity, they can be directly injected into our body. Even they have compatibility with many other drug ingredients, right? So in the agriculture industry, it is used as a delivery vehicles for insecticides, fungicides, pesticides, right? Apart from that, it allows the chemical to be effectively diluted and provides improved sprayability. So for spraying the pesticide at the field, this emulsification technique is also used, right? So in cosmetics actually it allows the dilution of the active ingredients to the optimal concentration. Even sometimes delivery, it will act as this emulsion will act as a delivery vehicle for many hair and skin conditioning agent. We use hair conditioner, right? This hair conditioner actually have the medicament which will be used as a conditioner, but that medicament it is supplied in the where it is supplied in a vehicle, that is the emulsion itself. So the next one, it is the surfactant technology. So reduce the odor and flammability. It is used. It have the benefits over the other solvent containing system. Example, you use your paint, right, inks. There we use. In the food industry, right, we use different types of emulsion in our food industry. For example, milk. It is the most stable type of emulsion in this world, right? Then you see the salad dressing. All of you have taken the fruit salad, right? In the fruit salad, we use the mayonnaise. The mayonnaise, it's a type of emulsion. Then the gravies, the sauce you produce, the sauces, right? The tomato ketchup, you used to see ketchup, right? They are generally produced by emulsification technique. Then the whipped cream, that is the ice cream we used to say, the whipped dessert toppings, peanut butter, ice cream, this all use the emulsification technique, right? Then even it is used in the fire extinguishing technique also, and it is very effective in extinguishing fire. At a small and a thin layer spills of the flammable liquids are thrown over the fire, right? In the pharmaceutical application, where it is used, it is used to cover the unpleasant taste of the drug. If the drug have unpleasant taste, it can be mixed with the emulsifying vehicle, which will cover the unpleasant taste of the drug. It increase the absorption rate. Why? Because it will slowly allow the drug to move out, right? So the extension of the drug release can be prolonged. Moreover, the topical emulsions, they are washables, so they can be used for topical delivery. They have high acceptable viscosity, so thus they can be used orally also. They are less greasy, right? They can be used for controlled drug release. They can be used for extended drug release. They increase the bioavailability. Yes, of course, because if the release it is prolonged, the bioavailability will be also prolonged, right? They can also prevent the drug, that is the thermolabile drug. I hope you know what are thermolabile drugs. Thermolabile drugs are those drugs which get deteriorated upon exposure to the high temperature. So thus, those thermolabile drugs can be incorporated in the emulsion for increasing their therapeutic effectiveness. Right? They reduce the patient's variability, means they generally shows the same action in all the patient. So now the last part, it is the storage and packing. So you see, depending upon the use, emulsion can be packed in the suitable container, right? So for oral use, oral emulsion, they are usually packed in a well-filled bottles having an airtight closure, right? Light sensitive emulsion, if we are using, then we should have to use a amber color bottle, because this amber color, what they used to do, this amber color, they prevent the entry, the amber color, they prevent the entry of the light into inside or into the container, within the container where the emulsion is present, right? So for viscous emulsion, you can use a wide mouth bottle, because if we use a narrow mouth bottle, it may not come out, right? Then the label on the emulsion should be mentioned that this product has to be shaken thoroughly before the use. For emulsion and suspension, it is a statutory unit, means or you can say, you can always add a comment or how to use that, shake well before use, right? So external products should clearly mention on their label that they are meant for external use only. For example, your topical one. Emulsion should be stored in the cool place, but refrigeration can be avoided or should be avoided, as this low temperature can affect the stability of the preparation, because the low temperature affect the action of the emulsifying agent actually, right? So thank you everyone, hope you like that class. So if you liked my video, just press the like icon, you can share this video, and you can subscribe to my channel. Thank you once again.